Everybody, it's Mr. Fillmore. Hopefully you watched video number 1 if you're in my honors class because it was your assignment. This is video number 2. It's section 1.3, and we're going to be talking about segments and congruence. But first, I want to start off with the challenge problem. So please pause your video before going forward and try it out. Okay, hopefully you paused it and tried it out. If not, then you're just watching. You get the answers right away. I'm hoping if you're in my honors class, you're at least trying the problem out, since we haven't done this in class yet. You will have a challenge problem similar to this in class coming up. So we're told in the directions that in the diagram, P, Q, R, and S are all collinear. They're all on this same line segment that's drawn in here. We're told that PS, the whole thing, is 46. And a good strategy is taking information from your directions and labeling it in your picture. We're told that PR is 18. And we're told that PQ and QR are the same. So I'm marking them with those two symbols, which we're going to talk about today, are congruent symbols, which means that they are the same. So we want to first of all find PQ. Well, if this whole thing is 18 and these both halves are the same, they're obviously both 9, right? So PQ is 9. That also means that QR is 9. So pretty straightforward. That's why I wanted you to try it on your own first. QS, we don't know this length yet. What we do know is that this whole thing is 46, right? And we know that this segment's 18. That's 18, and then this bigger, and the whole thing's 46. If we take the whole thing, 46, and subtract this piece that's 18, we end up getting 28, right? So with 28, that's our leftover piece here. So again, whole thing, 46 minus this first piece, 18, you get the missing piece, 28. Now that we know that, to find QS, well, from Q to S includes this 9 and this 28. If we add them together, we get 37. And then lastly, RS, we already found that's 28. Kind of went out of order here, but it was simpler to do it that way. Now, for those of you who paused it and tried it, you might have done it a different way. Maybe you would have not used the 18, but you would have used something with the 46 or the 9s. Tons of different ways that you could have tried this. I look forward to seeing some of them in class. There's just a challenge problem that's more about logic than anything else. You don't even need geometry really for this problem. It's more about logic. But let's jump into the geometry and the definitions that we need. Again, we're using segments and congruence. Congruent is something that's new that we're going to be talking about. So we're going to use this diagram to find GH. Well, if the whole thing is 36, and we know part of it's 21, you subtract 36 and 21, you end up with 15. There's your missing piece for GH. So GH equals 15. All right? Now, when you're doing a length of a line segment, you don't put the symbol above it. When you want a number, you just have to write GH. So without a symbol above it, you don't call it segment GH or line GH. When there's no symbol above it, you're talking about the length of GH. Okay? Let's move on to something else. This is called the segment addition postulate. We talked about postulates in the last section. Don't worry about calling it postulate 2. I want you to remember the name, segment addition postulate, which just says if you want to find the length of the whole thing, AC, then you add the two pieces together, AB and BC. So if this is 7 and this is 3, then if I add them together, the whole thing is 10. That's the segment addition postulate. You need to write this down because eventually the postulates that we learn and the definitions we learn, we're going to start using them to construct arguments. And you need to be able to reference what this says exactly. So regardless if you've ever done that before in a math class, you need to start doing it now. So pause it, write it down if you need to, because I'm about to change the page. All right, congruent segments has a very basic definition. I don't even know if I included it here. It's so simple. Two segments that have the same length. Congruent's almost like saying identical. But we're using it in geometry. Geometry has its own vocabulary, so we say congruent. If two segments are congruent, like these two segments, AB and CD, they're congruent because they have the same length. So we put a single tick mark through them to label it in our picture that they're congruent. Because in geometry, we look for lots of ways to eliminate having to write words and use symbols instead. So these symbols mean congruent. If we want to talk about length, like I said on the last page, you don't put a segment symbol above it. When there's no segment symbol, you're talking about length, so we're talking about a number, or like the size of something. If we do use a segment length, we're not just talking about length, we're talking about the shape itself, everything about it. So congruent to, we're not just talking about length, we're talking about the physical object, not just how long that physical object is. It seems like we're splitting hairs. I know it's such a small detail. Is it really important? Well, it's important at least that you know the distinction, not that it's really going to cause a huge change in the way you approach problems. For lengths, we use an equal symbol, and for segments, we use a congruent symbol. All right? So if you use a segment symbol, we're talking about congruence, you're going to use a congruent symbol, not an equal sign. So knowing these two distinctions, using length and equal sign, segments and congruent sign is important. If you can't see that congruent sign because it's too small on your screen, it's an equal sign with a squiggly above it. That squiggly is called a tilde from Spanish or French if you've seen that before. All right? So again, congruent means identical. With segments, it means same length. If you're talking about length, you use an equal sign, no segment symbol. If you're talking about the segment, the physical object, you have to use a congruent symbol. Okay? We're not going to do the coordinate ones because we don't really need them right now. But let's add in some algebra. Pause it and try it. Or if you didn't pause it, maybe now you're just going to listen to me. So we're going to find ST. Well, we don't know what x is, so we can't really find xt by plugging in x. We know these should add to give us 32, so maybe we should do something with x to solve it. So I know that if I add the smaller segments together, I should get the length of the longer segment. So, in that case, if I add 4x to 12x, it should give me the whole thing, which is 32. That's using the segment addition postulate. If you add the two smaller pieces together, it equals the length of the whole thing. So if I add 4x and 12x, if I combine my like terms, I get 16x. Bring down my equal sign, bring down my 32. Then you get x by itself. I'll divide both sides by 16. Well, 16 divided by 16 is 1, so it just cancels, and I have 1x, or just x. Then divide these, and I get 2. That is not my final answer, though, because it doesn't ask me to find x. It asks me to find st. So I know st, the length of st, is 12x. So really, that's 12 times 2. So the length of st is 24. Don't forget to plug it in. This is not your final answer. Your final answer is when you plug it back in, depending on what the question actually asks you, okay? For this one, they give you some stuff involving variables of x. They don't give you a picture. 9 times out of 10 in geometry, if they don't give you a picture, then you need to try drawing a picture. It's going to be extremely helpful. 9 times out of 10. Drawing a picture will be extremely helpful. So, I know the whole thing is kh. I know that jk is 3x, and I know that hj is 2x. Well, I'm obviously going to make the 3x one longer. So I'm going to make the jk the 3x. I'm going to make the jh the 2x. And the whole thing is 25. Now it looks more like our last problem, once I label everything. So if I add my two small pieces, 3x and 2x, and add them together, it'll equal the whole thing, which the problem tells me is 25. So from here, combining like terms like the last problem, dividing both sides by 5, x ends up equaling 5. It does not say find x anywhere. It says find hj and jk. So to find hj, I'm going to do 2 times 5, since x is 5, and I get 10. For jk, I get 3 times 5, which is 15. And to check your answer, your two small pieces should add together to give you the whole thing, which they do. 10 plus 15 equals 25. Another challenge problem, if you want to pause it and try it. Actually, that's the one we did earlier. My mistake. There's another challenge problem here you can try, or I'm going to move on unless you want to pause it. All right, 2 last definitions and 1 example, and we are finished with this video. So let's start with midpoint down here, and then we'll look at segment bisector. Midpoint is a point that divides a segment into 2 congruent halves. Remember, congruent means the same length. So if this half is 7, so is the other half. That's a midpoint, usually labeled as M. This is the definition of a midpoint, which will come up quite a bit this year, so make sure you note it down. Segment bisector is anything that passes through the midpoint. It could be a point, a line segment, a ray, or a plane. It crosses the midpoint. So it's still dividing it in half because it slices through the midpoint. So in this case, you could say line DC, or if you want to reverse the letters, line CD. It's a segment bisector. It passes through the midpoint. If you need to continue writing, please pause it. Otherwise, I'm moving on to the next slide. So point M is the midpoint for this one. Find the length of VM, this half. Well, kind of difficult because we don't know what X is. We can't just add these 2 together and set them equal to the whole thing because we don't know what the whole thing is. So what we will do instead is, since this is the midpoint and these halves by default are congruent, that means they're the same. So we'll set an equals in between them. So this first half is equal to this second half. To finish up with the algebra, I want my x's all on one side, so I'm going to try and bring this 3x over here. Since it's positive, I'll do the opposite and subtract. A little algebra review for you. 4x minus 3x is 1x, or I can just write x. The 1 is implied if I don't actually write it down. Bring down my minus 1, bring down my equal sign. 3x minus itself is 0, so it cancels. I'm going to bring this 3 down. Now that all my x is on one side, I'm going to bring all my numbers to the other side. I'm going to add 1 to both sides, and I end up with x is 4. Does the problem ask for x? No, it doesn't. It asks for Vm. In the problem, Vm is labeled as 4x minus 1. Well, x is 4. So I'm going to plug in 4 for x. And 4 times 4 is 16, minus 1 is 15. That is your final answer. That's everything you need to know about segments. If you're my honors class, you'll have an assignment in class. We'll do a lot of discussion with this. I'll answer all the questions. If you're my regular class, this should just be a review for you.